problem statement is creating a two-factor blockchain-based authentication where the user signs in a nonce instead of an SMS or an email address. So let us begin up with signing up. So we give in the following credentials, which will go to our backend, where it will verify when we log in, when we sign in. Let me be very clear that every email address will have an associated account. So we connect wallet here. Since we are signing up, we need to have a particular MetaMask wallet account with an associated email address. So I would like to connect account 2 with it, and it therefore shows account 2 as connected. So we sign up. Now we log in using the account we have just created. So our first factor authentication just ended, and now comes our second factor authentication using blockchain. Will be verifying using a nonce. So let me give a glimpse of what exactly will happen. So every account you can see that has an associated public address, which it is connected with a MetaMask account. That account has a public address. So all the details we saw, that the email address, password, and the public address had gone to our backend. So backend will be generating a nonce. It will send to our frontend. A MetaMask wallet pop-up will come up, and it will ask us to sign that nonce using the private key. So what will happen when we sign in the when we give our digital signature using our private key, our backend will compare the public address of the nonce generated with the address of the digital signature. If both the addresses match, then only it will verify that okay, the user has logged in successfully. So let me show you. We verify with our wallet. So we can see the generated nonce. This nonce has been sent by our backend. So, and this nonce that the backend has sent has an associated public address. Now we will sign in this nonce using a private key, and of, of course the private key will also have an address associated with it, which is public address of this account itself, because the private key and the public address will be of account 2 only, so it will have the same address. So this all these addresses will be compared in our backend. We confirm, and our dashboard logs in. We can also see the login history, uh, the username, the password, the wallet address, public wallet address, since it can be shown publicly, but the private key cannot be. So all these details has been sent from our backend to the MongoDB server, MongoDB database, and our front end has fetched that data from the MongoDB database. Now let me show you that if I use a different MetaMask account, if I use a different MetaMask account with a particular email address, will it be able to verify or not? So let me connect a different MetaMask account. So we go to our sign in page and we sign in using the same account that we just created. we can see that we have used, since we used a different account, we used a particular account for webaway@gmail.com. Now if we change the MetaMask account, I mean if we choose a different account, public address will also change. So let me show if it is verified or not. Account 2 is associated with webhavi@gmail.com. If we choose account 1, let us see if it will verify or not. So the nonce is generated by our account 2, which has this public address, and now we are signing in using a different account. So the public address will also be different. And in our case, since the public addresses will be different, it will not be able to verify. You can see that the verification is unsuccessful and it will take us to the login page. So this is how our two-factor blockchain-based authentication system will work, which is much better than the traditional SMS, alert or email-based authentication. Let me just show a glimpse of our backend. We can see that whenever the user tries to sign in, sign up, every data, even including the public address, is coming on our backend. The private key always remains secure and private with the user. Only the public address is being displayed on the backend, as public address is responsible for the comparison of both the indicators. So, but the private key cannot be displayed. It is always secure and private, and it remains intact with the user.